Okay, so the next rule we're going to look at for derivatives is called the product rule. You use it when you have two functions multiplied by each other, and for the definition, we use f of x and g of x. It can be any function. Sometimes you can just do algebra instead of using the product rule, but other times you need to use the product rule. So we're going to do a couple examples here, and then I'm going to probably do at least one or two more that you can just put on the back of this note sheet, or you can copy this into your own notes, however you want to do that. So the rule they wrote on here, we have the two notations, so in words and mathematical. So the rule when you're multiplying two functions and you're looking for the derivative is you take the first function and you multiply it by the derivative of the second function, and then you add. You take the second function times the derivative of the first function. So in words, the derivative of the product is the first times the derivative of the second plus the second times the derivative of the first. So we refer to the one listed first as the first function and the second one as the second function. So over here we have an example. We have 2x plus 5 equals 3x minus 2. You really could just FOIL this and then do the derivative, but we're going to use it to show the product rule first. So what we do is we take our first function, so we just copy it, 2x plus 5, and then we multiply it by the derivative of the second. So the derivative of this is 3, so I multiply it by 3, and then I add. Now I take my second function, 3x minus 2, and I'm going to multiply that by the derivative of the first function. So the derivative of this first function is 2. And after you do that, so that's the calculus, now what you do is algebra. So you simplify, so you distribute, so you have 6x plus 15 plus 6x minus 4. So I end up with 12x plus 11 when I simplify. So it's the first times the derivative of the second plus the second times the derivative of the first. Okay, so let's try the second example that's on the product rule notes. So to do this, I will take, I can't tell if it's a -2 or a +2. It must be a -2. All right, so it's x to the -2. So I'm going to take x to the -2. So I have x to the -2, that's my first function, multiply by the derivative of the second function. So the derivative of this function would be 4 times 2, so that's 8x plus 7. So that's the derivative of the second, so I'm going to write that in here, 8x plus 7. Plus, so now I take my second function, which was this, let's erase that, 4x squared plus 7x minus 1. So that's the second function. Now I have to multiply by the derivative of the first function. So the first function is x to the -2. And so I'll just kind of put it over here. X to the -2, its derivative would be -2 x to the -3. And I'll just leave it written like that for now until we simplify. So the derivative of that one was -2 times x to the -3. So to simplify, remember anything with a negative exponent needs to be moved so it's positive. So the first term, I would just have 8x plus 7 over x squared, and I would just leave it like that. The second one, this -2 is part of the numerator, so you can distribute the -2. So plus, -2 times 4 is going to be -8x squared minus 14x plus 2. And that whole thing will be over x cubed, because that x cubed, it was x to the -3, so that's the bottom of this term. Now, I'm okay with your answer like this. If you wanted to put it into a more simple answer, you would have to get a common denominator. And the common denominator would be x cubed. So then you would have to multiply all this one by an x, which it would work out. But for right now, let's just work on doing the product rule. And when we get more into more complex derivatives, we'll work on simplifying that. So now maybe just turn your paper over. Let's just try another one with how I would do this one. Like these ones up here, I really could have done with algebra. Like I could have just FOILed this and found this answer. This one I could have distributed this and got my answer. And my answer, if I would have distributed first, my answer would be a lot more simplified than this one. Because this one is not simplified because I told you not to get a common denominator, just to work on the product rule. Okay, so those two, I would definitely just do algebra and then take the derivative. Now the ones where I think that you have to use the product rule are when you have a function like, well, let's think of one here. Like the fourth root of x times 3x plus 2. This one, using the product rule, makes it a little bit easier. So let's see what that looks like. So I keep the first, the fourth root of x, and I multiply that by the derivative of the second one. So the derivative of this is just 3. And then I add, I keep the second, and I multiply by the derivative of the first. So the derivative of x to the 1/4 would be 1/4 x to the negative 3/4. So I get 1/4 x to the 3/4. So this side gives me 3/4 root of x plus 3x plus 2 over 4x to the 3/4. And once again, you can leave your answer like this. I can simplify. I could multiply everything by x to the 3/4 so that this was my denominator on each of them. And it would actually make this a little bit more simplified if you were going to do something with it. But right now, we are really just practicing the skill. And I know sometimes practicing skills isn't the best, but that's what we need to practice right now. So I would leave it just like that. Okay, so another thing that you can do with the product rule, and I like these examples just because they kind of just give it a number value so you don't have to think about it as functions. So this example says that your function is equal to the g times h. And you know that g of 3 is equal to 1. You know that the derivative at 3 is equal to negative 4. The h function at 3 is equal to negative 2. And the derivative of h at 3 is equal to 6. And I want you not to find this. I want you to find the derivative of f at 3. And so this problem is working with the product rule. So the product rule says I keep my first function, so g of x, so it's going to be g of x times the derivative of h plus my second function, which is h of x, times the derivative of g. And this one, they're just finding at a specific point. So you go up here and I'm like, okay, I'm looking for at 3. So I could replace all these x's with 3's. So I want g of 3 times the derivative of h at 3 plus h of 3 times the derivative of g at 3. And I plug in my values. So g of 3 is 1 times the derivative of h at 3 is 6 plus h of 3 is negative 2 times the derivative of g, which was negative 4. So 6 plus 8 is 14. So that means the derivative of f at 3 is equal to 14 because f was g times h. So this is a different way of looking at the product rule using numeric values versus function values. All right, so what I would do is I would try the practice sheet, the one that says find the derivative using the product rule. And I said you do not have to simplify. If you want to practice simplifying, that's fine. But just really practice the rule until I'm back.